Okay, question 13. Let z equal 2 plus 2i and w equal 3 minus I. Find the following, express your answers in a plus bi form. So what I want to do to make my life easy is just go to my graphing calculator and store these values for z and w. So I start 2 plus 2 times the number I. Remember, I is pi's cousin. I'm not using a variable I. I'm using the number I. Control in the var key to store, and that is z. Now for w, we use 3 minus, and remember, you don't want the variable I, you want the number I. Store as w. Now I can go through and calculate each of these commands using w and z instead of having to deal with all the i's and everything else. So my first operation is z plus w. Next, I have z minus w. Then we have 4 times w. Followed by 3z plus w. And one of the best things about this is it does not matter how complicated your computation is, because we're letting the calculator do the work anyway. Now for negative w minus 2z, make sure we start with the negative in parentheses for our w, but then we go to the minus sign for the 2z. And when we actually calculate this, the calculator shows us what it did, and that's how we verify that we didn't do something silly with our negative signs. Now, for question F, it says, what is the length of the vector representing z? So z is 2 plus 2i, and that's in a plus bi form. So what we want to do is put that into the formula, the square root of a squared plus b squared. So we have the square root of the quantity a squared plus b squared. So a and b are both 2. We're not putting I into this calculation. It's just the a and the b. So we square both of them. 2 squared plus 2 squared. Anytime you square 2, you get 4. So we end up with the square root of 8. But the square root of 8 is really the square root of 4 times the square root of 2. Now, we can't take the square root of 2, but we can take the square root of 4. So our result is 2 radical 2. And the reason I like this is because if I put 2 radical 2 in the calculator, I get that ugly decimal. If I put the square root of 8 in the calculator, I get that same ugly decimal. So we're just cleaning that up a little bit, and our result for the length of that vector should be 2 radical 2. And that's our review for the test on Module 1 tomorrow, Friday, December 10th, 2021.